Here we have the function f of x equal to the absolute value of x, and this is what the graph looks like. And we want to show that the derivative of f of x, it does not exist at x equal to 0, meaning at this point right here, there's no tangent line. And so far, for derivative of f of x, we have used this definition right here, but there's another form of the derivative of f of x, which is f prime of x, of f of x at x equal to a. And so the derivative at a is also defined as the limit as x approaches a of f of x minus f of a dividing by x minus a. So we want to find the derivative at a point, and then we can use this formula, or we can use this formula right here. And for this type of function, we can use either one, but let's go ahead and use the second one right here. So we want to show that the derivative does not exist at x equal to 0. And so f so here a would be 0, and then a here is 0, 0, and this is 0. And notice right here, let's write this down, f of 0 is just 0. So we have f of 0, and this is just 0. And the absolute value of 0 is 0. And the other thing that we need to know is that the absolute value of x, by definition, this is defined as this is equal to x if x is greater than 0, meaning if x is positive. So if the number in here is positive, so if the number inside the absolute value is positive, then the absolute value of that number is just that number. But if the number in here is negative, then this will be negative x. So for example, if we have a negative 4 in here, then we know that the absolute value of negative 4 is 4. And so if we do negative of negative 4, then we get 4. And so for this, if x is less than 0. So that's the definition for absolute value. And so this becomes the limit f of x is just the absolute value of x, which is the function f of 0 is just 0, and then x minus 0 is just x. And so we end up with this. And to find the limit of the absolute value of x divided by x as x approaches 0, what we can do is find the limit from the left of 0 and then limit from the right of 0. So we want to approach 0 from the left and then approach 0 from the right, and then compare the limit from the left and the limit from the right and see if they're the same or not. If we approach x from the left, approach 0 from the left, then we are to the left of 0. If we're to the left of 0, that means x is negative. X is less than 0. So one more time. We're letting x approach 0 from the left side. And so x is to the left of 0, and therefore x is negative, or x is less than 0. And therefore the absolute value of x is equal to negative x. But negative x divided by x is negative 1. and then limit of the constant -1 is just -1. And then for this one, we let x approach 0 from the right, meaning x is to the right of 0. We're approaching. So this is 0 right here. And so from the right, and then we let x approach 0. But we're still to the right of 0. So we are to the right of 0, then all these x values are positive, meaning it's greater than 0. So if x is greater than 0, then absolute value of x is x. And so this equal to 1. And limit of the constant 1 is 1. So limit from the left of 0, the limit as x approaches 0 from the left is -1. Limit as x approaches 0 from the right is +1. And so they're different. So limit from the left is -1, limit from the right is 1. And therefore the limit at 0 does not exist. So we let x approach 0 from the left side, we get -1. And we let x approach 0 from the right side, we get +1. So they're different, and therefore the limit at 0 does not exist. And therefore, whenever the derivative doesn't exist, we also say this. We say that the function f of x is not differentiable at x equal to 0. So if f prime of 0, or the derivative at x equal to 0, does not exist, then we say that the function is not differentiable at x equal to 0.